Now, then this part, what we learn is Dalton's law of partial pressures. What is Dalton's law of partial pressures? Dalton's law of partial pressure. Okay. So, what if you have a mixture of gas in a container? You have the container, you have nitrogen, oxygen, helium in this container. Do you think this gas is going to react? No, the gas is not going to react. So what about the pressure? So the Dalton's law of partial pressures says when the mixture of gases in a container, the total pressure will equal to the sum of the each individual gases. So P total equals P nitrogen plus P helium plus P oxygen. So if you add the pressure of each individual gas, it will equal to total pressure. So this is the law of total pressure. So what about, how do you find the pressure of each individual gas? In order to find the pressure of each individual gas, we have the equation, ideal gas equation. We can write P V equal nRT. So what about pressure of nitrogen? So let's take other than nitrogen to make it simplify. Gas, you have gas 1, 2, 3. Think about pressure of gas 1. So P1 equals N1 RT divided by V, right? Because it's in the same container, volume is same conditions, temperature is same. So P1 equals N1 number of gas moles of gas 1 RT divided by V. So what about P total? P total is N total RT divided by V. N total means total number of moles. So now if you want to get the relationship, P1 divided by P total equals N1 RT divided by V divide N total RT divided by V. So now if you divide in this way, RT cancel, V cancel, and then you get P1 divided by P total equals N1 divided by N total. What is N1 divided by N total? Excuse me. If I have gases, think about I have gas 1, 2 moles of gas 1. Gas 1, 3 moles of gas 2, right? Gas 1 and gas 2. So what is the mole fraction of gas 1 here? How to find mole fraction? Mole fraction is easy as this. Assume my class has 12 students. I have 5 girls, 7 boys. What is the fraction of girls in my class? You divide 5 by 12, right? You divide 5 by 12. That is a fraction of girls in my class. So you take the number of girls, divide by total number of students. Similarly, mole fraction is you divide 2 moles by the total number of moles, which is 5, 2 divided by 5. So this is the mole fraction. Similarly, N1 divided by N total is mole fraction for gas 1. So that is the mole fraction. So we are coming with the equation here. Let me erase it real fast. Here the equation P1 divided by P total equals N1 divided by N total, which is X1 mole fraction. And then you can come up with the equation again. P1 divided by P total equals X1 is mole fraction. You can always find pressure P1 equals P total multiplied by mole fraction. So this is the Dalton's law of partial pressures. In Dalton's law of partial pressures, we learn when there is a mixture of gases, the total pressure equal to the pressure of each individual gas present in the mixture You have to add the pressure of each individual gas to get the total pressure, and then we make the relationship using P1 equals N1, which is number of moles of gas 1 RT divided by V divided by P total, and then we came up to this relationship, which is partial pressure of gas 1 equal total pressure multiplied by mole fraction. Calculating mole fraction is a simple technique, which is you take the number of moles of that particular gas that you interest, divide by total number of moles. In this section, we're going to do some calculations using Boyle's law, Charles' law, Avogadro's law, as well as the ideal gas law that we did in the lecture part. So first, let's look at the calculation using Boyle's law. Let me read the question for you. So the question is, as you breathe, you inhale by increasing your lung volume. A woman has an initial lung volume of 2.75 liters, which is filled with an air at an atmospheric pressure of 1.02 atm. If she increases her lung volume to 3.25 liters without inhaling any additional air, what is the pressure of her lungs? So now you can look at the problem as you look at it. This is a Boyle's law problem. In the exam, I'm giving you the question and I'm not going to ask use Boyle's law. You need to know which law you need to use. Now when you read it, you should see the relationship. Okay, I'm giving you volume, I'm giving you a pressure, and asking again pressure, right? So in that way, you need to that comes to your mind, okay, this is Boyle's law question. So, and then while you look at the problem, you need to identify, okay, it has initial lung volume. What is initial lung volume? V1, P1. V1 is given, P1 is given. They give you also V2, asking P2. So let me explain in detail. So this is the Boyle's law question. So what is Boyle's law? P1 V1 equals P2 V2. In the question, the pressure is 1.02, which is P1 atm. Okay, 1.02. V1 initial volume 2.75 liters. They asking P2, giving V2, which is 3.25 liters. So now this is very simple question. The only thing is you need to identify the terms. So you divide both sides by 3.25, and you can find the answer. And I have the answer in this slide. You can see, you divide, you multiply 1.02, and then by 2.75 divide by 3.25, you see the answer here. So this is the answer for this Boyle's law question. Now let's go to the next question, which is Charles' law. So the Charles' law. So let's see what is the Charles' law talk about. Charles' law is a relationship between volume and temperature. So let's look at the problem. Our question is, a sample of gas has volume of 2.8 liters at an unknown temperature. When you submerge the sample in ice water T 0 Celsius, its volume decreased to 2.57 liters. What was its initial temperature? So now, looking at the problem, you can identify Charles' law is V1 divided by T1 equals V2 divided by T2. What is V1? 2.8, right? Unknown temperature. T1 unknown. That's important. And then V2 2.57. What is T2? Is it 0? It's not. Always in Charles' law you use Kelvin temperature. So 0 plus 273, it is 273 degrees. So let me write the Charles' law. Let's try this question. V1 divided by T1 equals V2 divided by T2. Our V1 is, it's given, which is 2.8 liters. Initial volume, initial temperature unknown. That's what we are looking for. V2 is 2.57. What is T2? 273 Kelvin. Okay, so then you rearrange the equation. You can isolate T1. You multiply both sides by T1. T1, T1, T1 come to this side, and then you have 2.8 liters equal 2.57 divide by 273 Kelvin, multiply by T1, and then you multiply both sides by 273, and then you divide both sides by 2.57, 2.57 cancel, and then you get the answer for T1, which is 273 multiply by 2.8 liters divide by 2.57 liters, and then you can see the answer in this slide, which is 297.6 Kelvin. So that is the answer for this question. So this question we are doing on Avogadro's law. What is Avogadro's law? V1 divided by N1 equals V2 divided by N2. So let's look at the question. A male athlete in kinesiology research study has a lung volume of 6.15 liters. During deep inhalation, at this volume, his lungs contain 0.254 moles of air. So that means, you know, volume, V1 you know, N1 you know. So, and then during exhalation, his lung volume decreased to 2.55 liters. How many moles of gas does the athlete exhale during exhalation? Assuming temperature and pressure constant. So let's look at the answer. It is V1 divided by N1 equals V2 divided by N2. V1 is 6.15. N1 is 0.254 moles. V2 is 2.55. N2, it's what you're looking for, right? So N2 is, you take N2 to this the other side, so you can multiply 2.55 liters in 0.254 moles divide by 6.15 liters, and then you get the N2. And when you get the N2, what is N2? N2 is the number of moles remain in the lungs, right? The lungs is the air mixture. But in this question, they ask how many moles exhale. So at that time, you have to get the number of moles at the initial, which is 0.254, subtract from N2. So let's look at the answer slide here. So in this one, you get the number of moles N2 as 0.105 moles, 0.105 moles, and then this is the number of moles remain in the lungs. Amount exhale is 0.254, subtract 0.105 moles. So that is the answer for this question. Let's see a calculation regarding using Avogadro's law. What is Avogadro's law? Avogadro's law is PV equals nRT. So let's look at the question. My question is, calculate volume occupied by 0.845 mole of nitrogen gas at pressure of 1.37 atm and a temperature of 315 Kelvin. So in this question, what are the information they have given? N is given, P is given, T is given. So there's another information. Another piece information is missing, right? What is that? R, gas constant. It's a constant. In the exam, I'm going to give the gas constant for you. So the gas constant here I'm using is R 0.802, sorry, 8, let me see in the exact value, which is 206 liters atm per mole Kelvin. So this is R. You need to use this R in the equation, in this question, they asked to find the volume. So PV equals nRT. It's easier if you rearrange the question at the beginning. So they have to find the volume, right? So I try to isolate volume in this side, nRT divided by P. And then I can substitute terms. N is 0.845 moles. R is 0.8206, which is gas constant. Liters, atm, mole, Kelvin, and then T is temperature, which is 315 Kelvin. P is pressure, 1.37. So once you substitute the terms, atm, you'll see, right? You see atm, atm cancel, mole cancel out, Kelvin, and you have only liters remaining. So if we look at the answer, the detailed answer in the PowerPoint, you'll see the answer is 15 point. So your answer is 15.9 liters. So that is the volume using ideal gas equation. So our next question, again using ideal gas equation, but to find the molar mass. So let me read the question for you. A sample of gas has mass of 0.311 gram. Its volume is 0.225 liters at a temperature of 55 Celsius and pressure of 866 millimeters mercury. Finds its molar mass. So let me write all the information that given in the question, all the data that we can get from the question, which is M is 0.311 gram, and volume V is 0.225 liters, and then it given pressure P is 866 millimeters mercury, and also I know something else, R, right? It's given, it's data, gas constant 0.8206. Okay, so these are the data given in the question asking molar mass. So if you write ideal gas equation, PV equals nRT, whereas molar mass can fit into this equation. PV equal N equals, N equals given mass divided by molar mass, right? So instead of N, you can write mass divided by molar mass, RT. So now you have to find molar mass. You isolate molar mass. So you multiply both sides by molar mass. Molar mass cancel here. M, PV, M, mass, RT. And then you divide both sides by PV. And M equals M, lowercase m, RT divided by PV. In that way you can find molar mass. You substitute. M is 0.311 gram. Another thing, R is 0.8206. What is the temperature? You can use 55 plus 273 Kelvin, which is 298, right? Sorry, 328 Kelvin. And then pressure is given in 866 millimeters mercury. Can you use this 866 with this R? No, you have to convert into millimeters mercury to atmospheric pressure. How do you do it? Remember, 1 atm equals 760 millimeters mercury. And then you take 866, you divide by 760 and then substitute it to this equation, and then volume is 0.225 liters. So pressure, important, make sure you divide 0.866 divide by 760, which is convert to atm, and then a volume is 0.225 liters. And then with that, if you look at this answer slide, you will see the answer, the molar mass as 31.9 grams. Okay, this question is from Dalton's law of partial pressures. Let me read the question for you. The question is, A 12.5 liter scuba diving tank contains a helium-oxygen mixture of 24.2 grams of helium and 4.32 grams of oxygen. At 298 Kelvin, calculate the mole fraction and partial pressure of each component in the mixture and the total pressure of the mixture. So in this question also, I will take all the information possible from the question, all the data. So volume is given, which is 12.5 liters, and then I know mass of helium, M helium, which is mass of helium, 24.2 gram. Mass of oxygen is given, which is 4.32 gram. Temperature, which is given 298 Kelvin. And then that's about it, right? And they ask you to find the total pressure and also mole fraction. So first, let's look at how to find mole fraction. What is mole fraction? So in this mixture, you have only oxygen. So you have this gas scuba diving tank, and then you have only oxygen and helium. Okay, and you know the masses. Helium is 24.2 grams. This is helium. Helium is 24.2 grams, and oxygen is 4.32. We know only masses. From masses, how to get mole fraction? What is mole fraction? Mole fraction is X number of moles divided by total number of moles. Number of moles divided by total number of moles. Can you find, since you know the mass of helium, can you find number of moles of helium? How to find the number of moles if you know the mass? Always number of moles given mass divided by molar mass. So given mass here is 24.2 gram, helium is 4. In that way you can find the number of moles of helium, N helium, and N oxygen is, again, mass is 4.32 divided by oxygen O2, it is gas, 32. In this way you can find number of moles of helium and number of moles of oxygen. So let's see what is the number of moles of helium. I am getting as 6.05 in helium, 6.05 in oxygen is 0.135. So this is helium and this is oxygen. What is the total number of moles? In total, you add, right? You have only helium and oxygen. So you add 6.05 plus 0.135. The total number of moles is 6.185 moles. So you know the total number of moles, and then you have to find mole fraction. Mole fraction is helium mole fraction, number of moles of helium, divided by total number of moles. X helium is number of moles is 6.05 divided by 6.185. Helium mole fraction. X oxygen, number of moles 0.135 divided by 6.185, and then mole fraction of helium is 0.978, and then oxygen 0.0218. In this way you found the mole fraction. So now this is easy, right? You didn't want to use anything, no gas laws, just number of moles divide by total number of moles. We finish mole fraction. Okay. This question has another part, to find the partial pressure of each individual gas. So for that you can find P helium equals, how to find it? You remember PV equals nRT equation. So then you can find, you can rearrange P equals N1 RT divided by V. Similarly, P helium, N helium, RT divided by V. You can find partial pressure of helium, and then you can find the partial pressure of oxygen, P oxygen, N oxygen, RT divided by V. If I substitute for helium, P helium equals number of moles of helium, which is 6.05, R gas constant 0.8206, temperature 298, given in the question. Kelvin, volume is 12.5. In that way, you can find partial pressure of helium. Similarly, for oxygen, you'd find the number of moles, which found from the first section, which is 0.135, R is 0.8206, temperature is 298 because it's in the same container, 12.5. You can find the partial pressure of oxygen and helium also in this way.